Okay, so let's look at question 31. It is saying that find the orthogonal trajectory to the family of curves y equals to 2x plus c. y equals to 2x plus c. So with this one, you know how to find the orthogonal trajectory. We differentiate first. So dy dx is equals to 2. So taking the negative reciprocal of this, that's just half. So we write dy dx is equals to negative 1 over 2. And then we try to separate the variables. So we have dy equals to negative half dx. And integrating. So if we integrate, that just y equals to negative 1 over 2x plus c. And so the family of curves will just be this. So that's question 31. Go to 32. We were given demand and supply of certain commodity are given thousands of units respectively. We have d to be equals to 100 plus pt minus 5p prime, and s to be equals to 70 minus 2p minus 3p prime, like this. So equating the two, we have 100 plus p minus 5p prime equals to 70 minus 2p minus 3p prime. So here we try to, if I send all of them across here, that will mean I'll have 2p prime and this p going here minus 3p, this one going here minus 30 is equals to 0. And writing this in standard form, that will be p prime minus 3 over 2p minus 15 all equals to 0. So p prime minus 3 over 2p is equals to 15. So right now, solving this, they are saying that find the price at any time t. So we find the integrating factor, which is the mu of t equals to e power negative integral of negative 3 over 2 dt, and integrating this get e power negative 3 over 2t. This is the integrating factor. So my p of t is just equals to integral of 15 times e power negative 3 over 2t dt plus c all over e power negative 3 over 2t. So if we do the integration well, here I'll just get negative 10 e power negative 3 over 2t all over e power negative 3 over 2t plus c e power 3 over 2t, like this. And so this and this will go, so I get c e power 3 over 2t minus 10. That's my p of t. Okay, and now is there a price elasticity? So I take the limit as t goes infinity of p of t and c. So limit as t goes infinity of time t equals to 0. They have given an initial condition which I can use to find my c. Okay. So at time t equals to 0, we have this to be 20. So at p of 0, p of 0 c e power 0 minus 10 equals to 20. So this will imply we have c equals to 20 plus 10, and that's just 30. So my p of t is equals to 30 e power 3 over 2t. Okay, minus 10. Yeah, minus 10. So we take the limit as t goes infinity of 30 e power 3 over 2t minus 10. So as t goes infinity, this goes to infinity. So we can conclude no price stability. No price stability. Okay, that's 33. So we've answered 32, 33. Write the form of the particular solution of this. So this is 33, and then this is 32. Okay, so 34. They are saying that we should write the particular solution of this y prime 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 equals to x squared. So the particular solution of this, oh, it will just be equal to, so the form will just y of p equals to a x squared plus bx plus c, and differentiating this 3 times, so y prime is equals to 2ax plus b, y prime prime is equals to 2a, and y prime 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 is equals to 0. So here what it means is that if we put 0 here, you see what we will get. We will not get anything. Okay, so so at this point, what do we do? So it means that we just have this as our particular solution, because when we substitute this inside, it will just be 0, and 0 is not equal to this. Okay, so it simply means that we'll the other variables, the variables such as b, c, and this, we don't know their values. We can't determine their values. Okay, at the third differential we can't determine their values. It doesn't mean that they are 0. No, they are not 0. Okay, so we just leave them. We leave them like this. We don't know what their values are at this point. So we just write this as our answer over there. So that is 34. Now 35, they are saying that 35. Okay, so 35, they are saying that a radioactive material have an initial mass of 100 gram. If the half-life of the substance is 6 days, how many days will it take the substance to reduce to 12.5 gram? That's a very simple question. The initial, the amount remaining at t, so the initial is just 100. It means a naught is 100. Okay. We all know the equation modeling is a of t is equals to a naught e power kt. That's amount remaining. Okay. Now they are saying the half-life of the substance is 6 days. Okay, it means that 0.5 of a naught at a of 6. Okay, so it means that the amount of time needed for the substance to reduce to half of it is just 6, and this is equals to a naught e power e power 6k, like this. And so we'll have 0.5 a naught equals to a naught e power 6k. Solving, we have 0.5 equals to e power 6k. So we'll just write ln of 0.5 equals to ln of e 6k, like this. And so if we continue to do this, we have 6k to equals to ln of 0.5. So k is equals to ln 0.5 all over 6, like this. This is our k. But they are saying that how many days will it take the substance to reduce to 12.5 gram? Okay. So now, at what time will this equals to 12.5 gram? Okay. So we have 12.5 is equals to the initial. What is the initial? 100 gram. 100 gram. So here actually, I think here would have been 50 and here is 100, because it was 100. Okay. So here that would have just been 100. So 50, 100, that's just 0.5 anyway. 0.5 anyway. Okay. So just like I was saying, it is kind of I think this is just the same thing. It is the same thing. If I even put 100 here and then 100 here, but this times 100 give me 50. If I divide through by the 100, I'll still get my 0.5. So it is the same thing. So coming down, we need a of t. At what time would our a be 12.5? That's the question we need to ask. But our k is this. Okay. And so we just have to equate 12.5 equals to 100 e power our k is ln 0.5 over 6 times the time. Okay, so here we just have 12.5 over 100 goes to e power ln 0.5 over 6t. Now taking ln of both sides again, so I have ln 12.5 over 100 goes to, if I take ln of this, I'll just have ln 0.5 over 6t, and so my t becomes ln 12.5 over 100 divided by ln 0.5 over 6. So if you use your calculator, well, I don't know what this will be, but if I use my calculator, I'll just have ln brackets of 0.5 over 100 versus over ln 0.5 over 6. And so you get your t to just be 18. So how many days will it take the substance to reduce to 12.5? That's just 18 days. So our question 35 is just 18. Now we go to question 36. Question 36. So we have find the general solution of y of 4 minus 16y equals to 0. General solution. This is a homogeneous higher order differential equation. So we can just write as lambda power 4 minus 16 equals to 0. Okay, and so this is just lambda lambda 2 or 2 minus 4 squared equals to this. And so solving this one, we just have lambda squared minus 4 in one bracket, lambda squared plus 4 in another bracket. And so this one here will give me lambda minus 2, lambda plus 2, and then here I will get this one actually I'm going to get complex root. So I'll get lambda to be equal to 2, negative 2, and if I equate lambda squared plus 4 equals to 0, that just lambda squared equals to negative 4. Taking root, square root of both sides, I'll get lambda to be equal to plus or minus 2i. Okay, so that will mean that I can write the solution like 3, 2, 4, 1 plus 2 goes to so right now that we have the solution is of two forms. We have a complex part and a real part, and so it means that we can then write our solution as this: y of x equals to c. So we have c1 e power 2x plus c2 e power negative 2x, this one, then plus our alpha is actually 0, so that will mean that even if we write this e power 0 x to brackets sine 2x plus cos 2x, like this. And so this will mean that we have c1 e power 2x plus c2 power negative 2x plus sine 2x plus cos 2x, like this. And so the solution for our 36 is this one here. It's this one here. Okay, so let's look at the 37. They are saying write the form of the particular solution for the equation. What is the equation? 37. We have y prime prime plus 4y prime and plus 4y equals to e power negative 2t plus sine 2t. So first we have to solve the homogeneous part so that we'll not be getting something like this. So okay, so let's solve the homogeneous part, and that will just be lambda squared plus 4 lambda plus 4 equals to 0. And so this will just be lambda plus 2 all squared equals to 0. So lambda is equal to 2 with a multiplicity of 2. Okay, there are 2. So right now we need to write the solution, but then what happens? The roots, this is 2. Okay, this is positive 2. It is not negative 2. Take note. If you solve it, I think, let me see, 1, equals to 4 equals to 4. Okay, so you get, oh, you get negative 2. Let me see. Yeah, it is actually negative 2. Okay. So we get negative 2. So since we get negative 2, um, and this one here is negative 2, so writing a particular solution, we have y of p to be equals to, it should have just been a e power neg 2t, but because of the negative 2 that we got in our answer, we multiply here by t. Okay. Then we add this one, 2. So that one there, we just have a sine 2t plus b cos 2t as that part. So the particular solution will just be of this form. Okay. Now 38. So this is 37 actually. Yeah. Now 38. What are they saying we should do? Find the general solution of y prime prime plus y prime equals to 0. So we have y prime prime plus y prime equals to 0. Writing the characteristics equation, now just lambda squared plus lambda equals to 0. So lambda out, lambda plus 1 equals to 0. Lambda equals to 0. And then lambda equals to negative 1. Now that will mean we have y to be equals to c1 e power, e power 0x plus c2 e power negative x. And so this is just 1. So I have my y of x to be equals to c1 plus c2 e power negative x. So this is my general solution. Now question 39.